Here we are, Flip Geometry at Hazelwood Central High School. My name is Mr. Llanos, along with Miss Robbins, who will also be doing some of these videos. We'd like to welcome you, and we're going to jump right into it. The first lesson here is going to be lesson 1.1, which is points, lines, and planes. 3 terms that we're going to define individually and take a close look at. After this lesson, you'll be able to identify and model points, lines, and planes. You'll also be able to identify intersecting lines. First thing we're going to look at is points. What is a point? Basically, it's just in geometry, a point is just a location. If you ever look at a map and there's a dot and it says, for instance, St. Louis, Missouri, you could say, hey, you've ever seen a dot on a map? There it is. There's a point in geometry. Okay, here's another point. Okay, it has neither size or shape. Doesn't matter how big or small. As you can tell, these two, or I'll make this one a little bit bigger here. It doesn't matter how big or small it is. Okay, how does it named? It's basically named by a capital letter. I can call this A, and I can call this point B. Okay, so I can continue to draw points, as many points as I want on here. Right now I've got 4 points, A, B, C, and D. When you go to name a point, basically you just write the word point A, and we all know that this is the point right here that refers to. Or I can write point B, point C, point D, but that's how we would write it out. If I were to draw a point and then another point, and I kept drawing points over and over and over again, closer together, eventually they start to look like something that resembles a line. It's exactly what a line is. It's an infinite number of points that has no thickness or width. Now, through any 2 points, I'll draw point E here, and let's draw point F up here. Through any 2 points, there can only be one line. And I'll make sure that you draw the arrows at the end, which signifies that it goes on in both directions infinitely. Again, any 2 points, you can only have exactly one line. So let's talk about naming this line. I would take any 2 points on this line. We only have 2, so we can name it E, F, and draw a line with 2 arrows over it. Or it doesn't matter which order the points go in. Okay, I can easily call this F, E, again with that same line, the 2 arrows over it. That signifies that it is a line. Now, it's important to remember that when using the geometry notation, you have to use the correct notation, and in this case, when talking about a line, that you draw a small line with 2 arrows on either side to signify that this is in fact a line. Now let's try a different line. Let me draw a line here. Oops. 2 arrows at the end. Let's go ahead and give it some points. Let's draw 3 points on here. Let's name this N, Y, C. Okay, we've got 3 points, 1 line. How do we name this line? Honestly, it doesn't matter. You could choose any 2 points on this line. So let's see how many different combinations we can come up with. We've got NY, YN. We've also got CY, YC. We've got NC. And then lastly, CN. Any one of these could be used to name this line. Choose any of the 2 points as long as you have the line with a little arrow above it. You have correctly named that line. There is one last way that I could name a line. For instance, if I had, let's draw a small line here again with the two arrows at either end, and I called this line M. I could just write that out, simply say that is line M. So far we've talked about points. I'm gonna go ahead and draw 2 points here. Let's call this one X, Z. We've also talked about lines. I'll go ahead and draw a line through X, Z. Okay, I'll just go ahead and draw some other points as well. Let's go ahead and draw this one here, D, E, and lastly, let's draw one more on that line, U. So we have a few points, one line. I can draw, let's go ahead and just draw one more line through these 2 points here. Now, the last thing we want to talk about is a plane. All these lines and points that I've drawn here live on a plane, which is, if you are looking at this on your computer screen, that computer screen, it could be viewed as a plane. It's basically a flat surface made up of points that extend infinitely in all directions. Now, I know your computer screen doesn't stretch out infinitely in all directions, but it's an example, a real-world example of what a plane might be. There is exactly one plane through any 3 points not on the same line. So I can say that X, U, D all live on the same plane. So how do we name a plane? Normally in a textbook you'll see a plane enclosed in a 4-sided figure that kind of looks like a tilted piece of paper. Okay, so let's talk about naming this guy. I would pick any 3 points that are not on the same line. So for instance, X, U, and D are not on the same line. Let's call this plane X, U, D. Again, doesn't matter what order the letters go in, I could easily say plane D, U, X, or name 3 other points that are not on the same line. Plane, let's go ahead and pick E, Z, U. It's just 3 ways to name this plane. In some cases, you'll even see a cursive letter in the corner of the plane, and you can also just name it plane S using that cursive letter. Here are just a few different ways to name a plane. You should already be familiar with the terms point, line, and plane from algebra. You should have already graphed on a coordinate plane that you see here and found ordered pairs that represented points on lines. In geometry, these terms have a similar meaning. Take a look at this figure and see how many things you can notice about it. I've got a plane P with 2 lines on it. Line N appears to be on plane P, but line R is not. It goes through plane P. I've got some points that are on line N, B, W, X, and Y. I've got 1 point on line R, T, and then just a random point on plane R named Z. What we want to take a look at now is collinear and non-collinear. Collinear points are points that lie on the same line. So if you notice, points V, W, and X, and Y, they would all be collinear. Non-collinear points do not lie on the same line. For example, points B, W, and T would be 3 non-collinear points because they do not lie on the same line. Another example would be points X, Z, and Y. They do not lie on the same line, so therefore they would be non-collinear. Coplanar points are points that lie on the same plane. For instance, V, W, X, Y, and Z are all examples of coplanar points. The only point that is non-coplanar is T, because it does not lie on the same plane. Lastly, the intersection of two or more geometric figures is the set of points they have in common. For instance, on the figure on the left, two lines intersect at a point. Line L and line M intersect at point P. In the figure on the right, we've got line R that intersects both plane B and plane A. At the same time, planes A and B intersect at line R. That's the end of the notes for lesson 1-1. I would take the next few minutes to try some of the problems that I've included in the rest of this packet. After you're done with those, please view the next video so you can watch me go through each and every one of those problems.